So for this unit, we've seen how to work with equations of lines in slope-intercept form. There are two different forms of the equation that we can also take a look at, and the next one we're going to study is called point-slope form. So if you look at the equation sitting here, you can see we have the slope, which we've been using for slope-intercept form, and then there's a point with x1, y1. When you look at an equation in point-slope form, you will see x1 and y1 as numbers, not variables. So m will be a number, the slope, rise over run, rate of change, and x1, y1 will be an ordered pair or a point on the equation of that line. Notice how inside the parentheses grouped with the x, we're subtracting the x coordinate, and outside the parentheses, we're adding the y coordinate. I like to think of the parentheses grouping the x and the x coordinate as an asylum. And here's why I call that an asylum. When people go to an asylum, it's because they don't act normal. So when you put that x1 coordinate into the asylum with the x, it doesn't act normal, it becomes the opposite. But the y1 that's outside the asylum is normal because we're adding it, so it keeps its value. So let's see how this works with numbers. So we're starting off with a basic point-slope equation. We're given the slope and a point, so all we have to do is substitute it into, as you can see off to the right, we're substituting it into the asylum equation. So first I like to write down the point-slope form of the line, x minus x1 plus y1. Remember, what goes inside grouped with the x isn't normal, it becomes opposite, and then what's outside stays normal. So we're going to directly substitute those values into our equation. M, or our slope, becomes 2/3. X and y are variables. The x1 and y1 are what change to numbers. So the x coordinate of our line is 9. 9 is positive, but when it goes inside the asylum and gets grouped with the x, it becomes negative. And then our y1, our y coordinate, is positive 4. It's outside the asylum, so it stays normal, it stays positive. So here we have it substituted into point-slope form, and then we're going to solve for y. Another way to say solve for y means rewriting it in slope-intercept form. The reason we like to rewrite in slope-intercept form is that for point-slope form, there are an infinite number of ways to write an equation for the same line. You can pick any point on the line and write an equation. But with slope-intercept form, there's only one way to write the equation of the line, because the rate of change is consistent, or the slope, throughout the whole line, and the y-intercept, where the line crosses the y-axis, is the same. So we like to use slope-intercept form. So when we rewrite an equation in slope-intercept form, looking at the right-hand column, step 2 says the first thing we do is distribute that slope. Make sure you only distribute it to the pieces inside the parentheses. What's outside the parentheses is not being multiplied by our slope. So we get y equals 2/3 x minus 2/3 times, and I'm going to put the 9 over 1 because I know a lot of you like to see a fraction times a fraction. You have an easier time working with those numbers. Remember, when you multiply fractions, you can divide first. This bar here means divide. So I can take my 9 and divide it by 3 before I multiply. So I end up with 2 times 3 over 1, which is just 2 times 3. So I get 2/3 x minus 6 plus 4, and then I can combine my like terms. So -6 plus 4 gives me a -2. So again, as a reminder, this equation right here was in point-slope form. And the way that we solved for it down here was in slope-intercept form. We're going to do the same thing, but this time we're looking at our equation on a graph. So we need to determine what the slope is. Remember, slope on a graph is rise over run. So you can draw your triangle, count up, we went up 1, and then count your run, we went over 4. So our slope for this line is 1 over 4. We know that it's positive because the line is rising. Another way that we know it's positive is because we went up and to the right. So those are both positive values. Next, we can choose any point on the graph. We have two options here that are highlighted for us. We could choose the point 2, 7, or we have another point over here that's also highlighted, which is -2, 6. It doesn't matter which point you choose, because the first example we saw where both values were positive, I'm going to choose the second coordinate to write our equation. So starting by setting up our point slope formula, substituting what we know our slope is 1/4. We know our x value, again I'm using the second coordinate right here, is -2. So when I put it into the parentheses or into the asylum with the x, it becomes opposite, so now it's a +2. And our y value stays normal because it's outside the asylum, so it stays a +6. Again, this version is the point slope form of a line. Now we're going to solve for y, simplify this expression, and we'll put it into slope-intercept form. So we start by distributing our slope. 1/4 x plus 1/4 times 2/1 plus 6. We've got y equals 1/4 x. Now when we divide this time, 2 goes into 4 twice. Our answer is left in the denominator. So we get 1/2 plus 6, and 6 plus 1/2 is 6.5. So we have y equals 1/4 x plus 6.5. So again, what we just did was rewrite this into the slope-intercept form of the equation. And finally, we're going to take a look at how to graph an equation from point-slope form. If you're looking at this example, you might notice it's set up a little bit differently than the way I set up my point-slope form. And that's because this is actually the real version of point-slope form. I just don't think it's very easy to use, so I switch it around a little bit to make it what I think is a bit more user-friendly. However, you do need to work with this version because you'll see this form on our tests and quizzes because some of the other teachers use the real form of point-slope form. So the first thing that we do is simply modify this so that it looks like my version. So I'm going to add this 1 to both sides of the equal sign. So we get y equals -1/5 x plus 3, and that plus 1 goes on the outside. And then we can identify our slope and point. The slope is what we're multiplying by, that's our -1/5. And the point is the x value is grouped with the x, and it's not normal. It looks like a 3, so it's actually a -3. And then the y coordinate is outside, and it is normal. It looks like a +1, and it is +1. When you graph, you have to have a point to start from. So you cannot start by graphing the slope. The slope is a rate of change between 2 points on the graph. So you can't start with a rate of change, you have to start with a point. So we're going to plot our -3, 1 first. And then from there, we can use our slope of -1/5. Now remember, when you have a negative slope, your line should fall. So you can go down 1 and right 5, or you can go up 1 and left 5. What you have to be careful of is that you don't make both of your values negative. It's really tempting to go down and left because students are thinking negative, but remember, going down is negative and going left is negative. And when you divide a negative by a negative, it becomes positive. So you would actually end up graphing a positive slope. Make sure when your slope is negative that your line falls. Your line and your slope should match, so make sure that you're consistent. And please try these 2 questions before you come to class.